All right, cool. I'm going to get started. So welcome to this talk about efficient sad puppy layouts. If you're wondering about the title, then you clearly don't have the iOS version of the Droidcon 2016 app, which apparently was submitted and was rejected for using the word Android. So the word Android got replaced everywhere with sad puppy, and so I figured I should match what iOS is saying. So if you don't get this, you should get an iPhone. And a quick note before we begin. I don't know if you noticed yesterday when you're in this room that like someone's playing lights out with the lights all the time. So it ends up looking like this half the time, and it's sort of distracting as a speaker. And so my proposal to you is if someone in the back leans on the light switch, then someone owes me some money. So I'll take PayPal, Venmo, Square Cash, whatever. It's fine. So all of that is a cover basically to excuse the fact that I have no transition for anything here. I'm going to talk about basically ways to like leverage yourself as a developer to do like a lot of work at once in Android layouts. And it's just a grab bag of things, so I don't really have any great like story arc to go on. So let's just jump straight into view groups. And in particular, like picking view groups, since I said I would talk about it on the abstract. And generally speaking, the way that I look at view groups is sort of complex to simple, and I really always try to go for the most simple view possible. So like high up on the complexity scale, you have things like RelativeLayout, and then kind of equally so, although I'm guessing it'll get more complex over time, is ConstraintLayout. Then somewhere in the middle of that is like LinearLayout, and then down below is FrameLayout, which is like my favorite thing ever. So to go a bit more into detail on those, for RelativeLayout and ConstraintLayout, really what it's all about is the ability to position views relative to each other. In RelativeLayout, it's very simple positioning relative to each other. ConstraintLayout, they're adding more and more features for more and more complex ways to be relative to each other. But in general, both of them are sort of difficult options right now. RelativeLayout is just slow in general and has all these weird bugs that you can run into. And ConstraintLayout looks great, but it's in alpha right now, which means it's a little bit unstable. I think it'll stabilize very soon, but for example, like a new version of it was released yesterday, or maybe it was like 2 nights ago, but like very recently. So I actually looked through the Trello app in order to find like all the places where we were actually using a RelativeLayout, and I found one instance where we were using it correctly, and there were 4 other instances where we could have just replaced it with something simpler. So in general, I think the editor for a while defaulted to RelativeLayout, and some of the XML still defaults to it, but I would sort of avoid it if possible. LinearLayout, stacking views horizontally or vertically. Very simple, kind of amazing if you realize that iOS didn't have a view like this until like a year ago. I don't know how they did anything. Probably just putting things directly on pixels, because they could do that. It's nice for the stacking, because that's a very common idiom. It's also nice for weight distribution. So like on this screen, you have these rows stacked vertically, and on the top row, you kind of have this split spinner that's distributed equally on weight. So nice and simple, but the frame layout's really the one that I love, and I feel like does not get nearly enough love in all of these talks, because it's super simple, and all you can do is position based on the parent bounds. So that is, you can position any child view like in the middle of the view group, or you can position it on any of the cardinal edges of the view group, like north, south, east, or west. And it turns out that that's really all you need a lot of the time. It's really good for overlapping views. So if you need 2 views that are on top of each other, FrameLayout's a real easy option for getting those to overlap properly. And it's really handy for like clickable item backgrounds. So if you have some image or something that takes up a very small amount of the screen, but you want to have, when you click, take up a large amount of the screen, it's very easy to just slap a FrameLayout on it and have like a clickable item background there. So a good example of that in the Trello app, which we apply all 3 of those principles, is the notification bar up there in the corner, which I will now inflate so that you can actually see it. That one, the icon in the middle always shows up, and then like the little red unread number shows up whenever you have unread notifications. And the icon itself is positioned in the middle. The red circle is positioned in the upper right corner. And then I'm using margin in order to like push it off to the side, so it doesn't have to be slammed up against the corner of the frame layout. So it's very simple positioning based on parent bounds. It allows me to overlap them in a nice little way. And then the image view itself doesn't take up the full space, and so it has a clickable item background for that frame layout. So it's very easy to do all of this stuff with FrameLayout. I highly recommend using it more often. Another thing I use it for often is as a what I call like a toggle container. So where I've got two views that occupy the same space and I'm toggling between those two views. So a good example of that is an avatar view that we have all over the place in the Trello app, where this represents like a member of Trello, and then if they have an avatar set, then we load that avatar and display it. If they don't have an avatar set, then we decide to show just their initials instead with some colored background. And that is just like a frame layout with with an image view and a text view inside of it, and we can switch between the two, and they just switch in place. So this avatar view brings me to my next layout thing, which is view reuse. So here's just like 3 screens from the Trello app, and we've got like the avatar view all over these. Like we've got them on the cards. When you open a card, we can show the number of members. If you're showing like the activity on the board, we've got like the member next to each one of them. And it would be really cumbersome if we had to re-add this code many different places in the app. So what's the most efficient way then to like reuse a view in multiple places? One option is to use an include. So I've got this parent linear layout, and then inside of it I have this included code. And the include tag, if you've never seen it before, you just point it towards another layout, and essentially that layout is just put in. It's like you copy and pasted that layout into this one. And then you also get the added bonus that you can, you generally can't mess too much with what you've included, but you can mess with the layout parameters, so if you want to like change the size of the included layout. So that's all well and good, but the problem then becomes, all right, I've got the views in there, but I don't have any of the logic. So then I'd have to duplicate all of the binding views, or grabbing views and then binding them to data. I have to duplicate that all throughout the code. So what I really prefer these days is creating just a custom view group. And I'm not saying a custom view group from the perspective of like, oh, I'm going to do all this drawing myself or something complicated like that. It just is a placeholder for that include, essentially. And so now instead of having include, I'm just saying inflate this avatar view directly. And then what I have is this class which actually implements avatar view. It extends the frame layout, so it's got the same root frame layout there. And then in the constructor, I actually do the inflation of the layout that I was originally going to include. And then I also find view by ID or data binding or whatever in order to get all those that data. And then I have some bind method that can figure out a logic of like, should I be loading an image in or should I be loading the initials in? And then this makes it really easy anywhere in the app then to include this one view and then just start using it. And there's one thing I want to warn about for this method, which is that, so imagine this is like the XML for the actual avatar view that I'm including. So it's got this frame layout, a text view, and an image view. The problem is that when you use this method, what you end up with is a kind of view hierarchy like this. So the avatar view itself extends from the frame layout, and then it inflates a frame layout inside of it, which then has a text view and image view. And so the problem is then we have this worthless parent here, frame layout, which is actually doing us no good whatsoever. So the trick to get around this is actually in how the inflation works. So a lot of the times when you use layoutinflator.inflate, you actually pass a third parameter, which is false. If you've ever wondered why you're forced to do that, it's because of this, which is that normally if you don't pass false, it defaults to true, and it tries to bind what it just inflated to the current view. And most of the time that is not what you want, but in this one case it is what you want, because then for the included layout, instead of having a parent frame layout, I can use a parent merge. And merge basically says like, I don't actually have like a view parent defined right now, I'm just going to merge with whatever inflates me. And the end result then is that you get a view hierarchy like this with the avatar view included with no worthless frame layout in between. All right, let's move on to the next topic, styles. So styles are a simple way to reproduce attributes across views. So if you have a view without style, then I've just got the attribute there directly on the view. Whereas if I were to extract it, I would have some style that defines the Android background, and then my view itself would reference that style. So this is obviously a clear way to reproduce code across the app. And I like to use it when there are what I like to call like semantically identical views. So a calculator is a really good example of this because there's all these buttons on the calculator and you want them all to look exactly the same way. Another way to put it is that if one of the style views should change, they should all change. So if I want to change the text size of like the numbers, clearly I want all of them to change at once. So this saves me a lot of time because then something that's supposed to be identical across the app, I just change it in the style and instead of having to go throughout the app to all the different instances of that view and change it. However, I want to warn against some usages of styles that I think are actually highly inefficient. And one is a single-use style. So you have a view and you have a style, and that style applies just to that one view. It's so easy to make styles after the fact that like I don't know why you'd add this level of indirection when you don't need it. But the more problematic thing is when you apply a style where there are two attributes that match up just coincidentally. So imagine when I first write some layout, I have two text views, and it turns out, hey, look, they have the same text color and text color hint. So that seems like something I should style, right? But if you then look at the title or the IDs, you can tell that one's supposed to be for the title text and one's supposed to be for the body. And the difficulty becomes like, what if I decide the body text should be a different text color? Do I then change the style? But if I change the style, then I accidentally change the title. I could override the style, but then the style becomes sort of meaningless. And when you create styles just because things are coincidentally the same, you end up kind of like somewhere down the road, it becomes very difficult to change your code. I liken this to like, if you think of this in terms of Java code, imagine I have like two constants. One constant, which is like the number of columns in say like a staggered grid view. And then the second one is like the number of retries for some network request. And I say, hey, look, they both have the number 3. I'm just going to extract this into a better constant, which is the number 3, which is ridiculous from two perspectives. One, 3 is already a constant. But the other problem is that like I've lost all semantic meaning here. Like if I want to increase the number of rows on a staggered grid view, I've suddenly changed the behavior of how many times I retry a network call. So that's why you shouldn't just make styles out of coincidental matchups. So styles are really great when you are, but you have to apply it to each individual view that you want to apply it to. Themes are essentially like styles on steroids because themes, instead of affecting a single view at a time, it affects multiple views at once. So anything you do in a theme can potentially affect the entire app. It's very good for that. It's very good for setting up default styles. So you might create your own custom button style and think, okay, I need to go now and apply this style to every single button in my app. In themes, you can actually instead just say, I want all of my buttons to look like this by default. And then also what's really handy is that you can use it to configure system-created views. So things like pop-ups where you're not necessarily making it yourself, you can apply the data to the theme, and then the theme can apply it to the views automatically, and then that's one less thing you have to worry about as a developer. So in terms of applying themes, you can apply it at an application level, and then it gets applied to all the to everything that doesn't have a different theme applied. You can apply it to the activity, or, and this is the most interesting one, is you can apply it to views. And this is sort of a recent development of like a few years ago that some people still don't know about, but you can apply a theme just to the view, and then it applies to that view and any children of that view. And this is really super great because before this, in like the Hollow days, we used to have like if Hollow a light theme with a dark action bar, and that was the entire name of the theme. Because there was no other way to separate out like that most of this would be light and that the toolbar would just be dark. Whereas now, you can just say, I've got a material light theme, and then for the toolbar itself, you can say, I want to apply a dark theme to it. So it's much easier for composition of themes. It also saves you all this trouble where you're trying to like mix up light and dark on your app. So I'd recommend, before getting into themes, to really check out AppCompat and start using it if you're not already. For one thing, it adds material on all devices, and maybe you don't like material, but I know what you won't like more is having to deal with both material and Hollow at the same time, because they very subtly change padding and margin and assets, or even just the visual language of how different widgets work. So it's a lot easier to work from a single baseline. Again, like it's much more efficient to like only have to modify once. It also provides a bunch of baseline themes and styles. So if you want to create a new button style, but you just want to like take one and modify it slightly, it's a lot easier to do that with AppCompat. If you don't have AppCompat, then you end up having to create like multiple styles for different versions of Android. And then the third thing it really gives you is it enables view theming pre-Lollipop. So that the view theme was added in Lollipop, and amazingly they were able to backport that, which is really awesome. So you don't have to worry. That's a feature you can actually use this year instead of waiting like 5 years from now when Lollipop becomes the Min SDK version. So just a brief overview of some of the things you can do with themes. One of the things that keeps getting touted over and over again is that you can set up colors. You can color all of your widgets from a theme. So then instead of having to go color every widget individually, you can basically set up a baseline coloration for your entire app. This is sort of a demonstration of those default styles I was talking about. So I can say that I want my button style, or my button style everywhere is going to be my button. The spinner item style below that is sort of interesting because then anytime I automatically inflate a spinner drop-down item, it'll apply that style to it. So I'm not even inflating those myself. It just applies that automatically. Or I can set up like default text appearances. So in my text views, I can even apply a different style to that text view, but it'll get the text appearance from here by default. And another example of this is where themes are powerful is that you can put attributes into the themes and then reference them in your views. So I can say that I would like my button's background to be this question mark attribute selectable item background. That question mark attribute means I'm going to draw that from the theme. And then I can set up the drawable item background in one spot and apply it all over the app. So generally that's not super great because like why don't I just reference the drawable directly? Well, this is actually pretty nice because what if the selectable item background is set up by default to be something really awesome? So for example, like from Lollipop on, I believe it has the ripple drawable for the background. Previous to that, it's got like a different drawable. Here you can just let the theme take care of figuring that out for you. All right, next subject is resources. I'm going to get a drink of water while you all look at that picture. All right, how to use resources really well. So before I can get into like resources, I want to talk about device configuration. So the device configuration is this set of attributes that defines how the device is set up at the moment. So what can we say about the device right now? We can say that it's in portrait orientation. It's stood upright. I know that it is 731 density independent pixels tall. I can say that it's 411 density independent pixels wide. I can say that the density is XXX HDPI for all of the assets. That's like the default density. It's in English right now, and like the version of the operating system is version 24. So this isn't like the full set of configuration values, but these are like most of the ones you normally deal with. And all of these, some of these things can change during runtime, some of them can't. So things like the orientation can clearly change very easily. The width and height changes depending on the orientation. The user could go in and change their locale, but some things like the density shouldn't really change, and then really like the version of Android that I have installed, I really hope doesn't change while the app is running. But what you often do as a developer is that you want to take advantage of these different device configurations and display different layouts or resources or UI based on that. So a very simple example is a different UI based on the orientation of the device. So this is the built-in calculator app. In Portrait, it's got enough space for like the buttons and a few simple arithmetic operations. And in Landscape, it's got a lot more space, so it shows all of these interesting functions off to the right. Another classic example is translation. So this is like a settings of an application. On the left we have the settings in English, and on the right we have the settings in Japanese. One of the things too is you can do it based on the screen width. So on a phone where it's got a pretty small width, we just decided like when you open up a card it's going to take up the full screen. But on tablet, even though this is in Portrait, we decided it looks a little silly if you like have this take up the entire width, and so we kind of start adding a margin breakpoint to that card. And then you can have another example of like things based on width. We have this like search screen, and on the search screen it can show a number of different staggered grid items, and that number is determined based on like how wide the device is. And so what this is all, you could do this all in code just by like grabbing the resources and looking at the device stuff, but Android has this whole resource qualifier system which you can leverage to make your life a lot easier in this regard, where it basically allows you to define alternative resources for different device configurations. So that means that you can define when resources should be picked based on a number of qualifiers, and then Android will just kind of like automatically pick the right one for that current situation. And by the way, as an aside, this is why overriding config changes and handling them yourself is usually a bad idea, because if you do that, you skip by this whole system entirely. And so, yes, maybe you've saved a little bit of work having to like save data to your activity, but the downside is now you have to do all of this yourself. And I would much rather have the system do this and then actually properly handle configuration changes. The other problem with configuration changes often being that people just say, oh, I'll handle like orientation configuration changes and not realize there's like 10 other ways that the configuration could change at runtime. So the way that it's defined is that in your res directory or resources directory, you just put dashes in the qualifiers for like the actual attributes you want. So the one up here, this is just my default values folder. It's got no resource qualifiers to it. Whereas this middle one here, drawable-xxx HDPI, it's got one qualifier added, the XXX HDPI one, and then below that I've got 2 qualifiers, and you can add as many qualifiers as you want, really as many as the system has, although I'll warn you that you have to put them in a particular order. So if you're going to have multiple qualifiers, go look at the Android resource documentation, and it lists out, like, it has this big table of all the different qualifiers you can use, and it lists them which order they have to be in order for it to actually work properly. And that documentation also has like the specific algorithm for how it determines which resources, but essentially it goes from the most specific to the least specific. And so, like, imagine that I have this values SW600DP port. So that has 2 qualifiers. And so it would pick from there if it had those 2, but imagine like, oh, it doesn't actually have, it's either not in portrait or it's not that wide. So now I'm going to check to see if values SW600DP works. Oh, it turns out it's not that. I'm going to go check if values port works. And if it's not in portrait, then it'll fall back to like the default value. And this is why in most cases you should have like a default value to fall back on. And that you generally need it for everything except for drawables. Drawables is this sort of weird special case where it'll actually like scale the drawable if you don't have one for the specific density that the system currently has. So in terms of using this system correctly, I'd like people to think of resources as code. Don't think of it as like just a place where you grab layouts and stuff. Think of your resources as parameters that you're filling in to parts of your app. And then that parameter is determined by the device configuration. So to think of it in terms of like Java code, on the left is maybe a very inefficient way of squaring numbers, because I'm going to have to write a new method every time I want to square a different number, versus on the right I have something I can actually put in as a parameter and then it squares it for me. So a whole bunch of examples of how you can use this. Suppose I want to just know whether the phone is in portrait or not. Ignoring the fact that you could just go get resources and like find this out, I can have some Boolean that I define is portrait, and then by default in my default values, I can say is portrait just false. And then in values-port, where I know the only thing that's qualifying it is that it's in portrait, I can say that it's true. And so now I can grab this Boolean out of the system and know exactly when it's in portrait or not. And then you can extend this to like if you want a specific set of device configuration qualifiers to happen before some action occurs, you can set that up pretty easily. Another pretty classic example is set content view. You want to include some layout, and so maybe you've got a layout default, and you've got a layout in landscape orientation, a landscape and portrait orientation. I believe that the default layout here would only show up if you had a square screen. But this is sort of a pain because like there's probably going to be a lot of duplicated code between the different activity mains here. So what's better in this case is actually to just have the parts of the view, or the parts of the view hierarchy that change, split out. So let's imagine this is my activity main here, and it's somewhere in there I have an include that points to some include. And then this is how my directory structure looks. So everything that doesn't change between the activities just is an activity main, and then for landscape orientation I have one set of layouts, and for portrait orientation I have a different set of includes that like has different views set up. Or let's look deeper into that include. Maybe both of them have like a text view that's supposed to look the same, except for that one of them has a slightly different text size from the other. So what sucks is that like there might be like 10 different attributes and the only thing that really changes is the text size. So why don't we just do that through the resource qualifier system instead? So instead, let's say the text size points at some dimension resource, and then that dimension resource is defined in two different folders, and one time it's 16sp and one time it's 24sp. And then the same problem can be applied not just to an individual text view, but then you can apply it to a style. So this style then could be applied to many, many different views throughout your application, where you have the same problem here. Oh, I'm having to write two different styles just because one attribute's changing. I can do it in a single style and then have it reference dimensions. So really you can have this whole graph of like changes all the way down. So I might have at my top an activity main, and there's sort of a decision tree here. So by default, it's going to include some include here versus include that depends on it being in portrait orientation. And then both of those includes happen to include a text view, which sort of represents the same thing. And it has this style applied to it that's a welcome text, and then that welcome text style itself has some text size that's determined based on the different width of the screen. So this can basically nest all the way down. You could make a huge mess of this, but if you use it correctly, if you're smart about how the different breakpoints happen with resource qualifiers, you can end up having basically no duplicated code whatsoever throughout your application, which is great. Things just change based on all of the different device configurations. All right, drawables. Let's talk about drawables and how we've made this a lot more efficient in our application recently. So I'm going to paint a nightmare scenario for you right now. So I'm talking to design, and design sends me a beautiful mock-up of a new screen. And I look at the new screen, and I'm supposed to add this like login with SSO thing at the bottom, but there's this icon. So I tell design, I need to have a copy of this icon asset in order to actually implement this. Fine, makes sense. So design then, a couple days later, sends me a PNG. And they send me this private, who knows what DPI this is in? Who knows what they intended for this? So then I go to them and I say, okay, that's not enough. I need it to actually be like, I need, the different densities for my screen. So then they send me back this, which I then have to go and rename every one of them and put them in the right directory structure and then put it all in. And then at the end of all of this work, design says, oh, I tweaked the color of it slightly, and we need to go through this whole process all over again. So if anyone else has gone through this, it's nightmarish and was basically like the Android design interaction for 5 years or so. But I think there's so many ways to solve this stuff. It's great. And basically, as much as possible that you can make assets code, you should do so. Basically skipping the designers as much as possible. No. No, they're still heavily involved in this, but you can do a lot of tweaking and a lot of the design in code. It becomes a lot simpler to manipulate it later. So one thing that's sometimes overlooked is that there's a whole drawable XML system that's been built into Android since the very beginning. Now it doesn't allow you to do that much, but what it does allow you to do is enough to get by on some very simple shapes. So yeah, it's built into Android. It allows you to do simple shapes. It allows you to create state selectors, which are actually fairly important. So like when you're clicking a button and it looks different as you click it or as you click and hold, those are different states. It allows you to layer things. So if you have two maybe very complex drawables, but you want them on top of each other, you don't have to create some composite of them, some composite ping, and put it in your app. You can actually just layer them on top of each other in XML. So a good example of this is our login buttons on the Trello app, which are actually entirely through Drawable XML. And so let's start with how the button outline is created. So this is one file on its own. And this one is just a shape drawable. The background is blue. The only reason I have it there is because otherwise you couldn't see the white since my slides are all white. But so we've got a shape drawable. We say the shape is going to be a rectangle. You can do things like ovals as well. We're going to say that the main color of this shape is transparent because we mostly have it be see-through to see through that blue background. But we add this stroke around the edge, just this white stroke. And then on top of that, we say that the corners are going to be, and again, here's the dimension. We can modify it based on the size. But the corners are going to be this little thing to give it that nice little curved look. So that's just the basic outline, but at this point we have no interactivity. So if you click on it, nothing would happen if we just use it like this. So what we really need to do is create some sort of selector. So this is a second file that we have now that references the first one. So this one is actually a layer list at the top. So it's two drawables layered on top of each other. And one of these drawables is the one I just showed you. So we're saying always on top is going to be this rectangle, this outline. But then below that is going to be a selector. And that selector is going to change things based on whether you're pressing it or not. So when it's pressed, it shows that it shows this little solid image with the shape being a rectangle, and it fills it in with this solid color. Now I don't worry about any stroke, and then it's got the same corners so that it doesn't bleed outside of the outline that's drawn on top of it. Oh yeah, and this cool little GIF that's there too. Yes, you can see how it looks. And then when it's not pressed, we just say it's transparent. So don't show anything when it's not pressed. And that's how we get this effect for the button selector. But then on top of that, the buttons have changed recently in the last few years, which is that we have these cool ripple drawables now. So now instead of just having a flat color, we can have this cool little ripple effect when you click on it. And that's done a whole different way. So now we've got a third file here, which we're using just on version 21 and above, that's using a different set of drawable XML attributes. So that last one's completely ignored. We're just using this one here for the more modern versions. And this one has a ripple as the top level. And there you define what the color of that ripple is going to be. And it's the same color referenced in the last one. And then one of the layers then is the actual drawable itself. Again, that outline, so we're always including that layer. But then for ripple drawables, what you do is define what's known as a mask. And that defines the area that the ripple can actually show up in. And then again, in that mask, we have a shape defined, which is the shape of the actual outline. And then Android itself handles because the solid color and all that stuff doesn't really matter. It just handles where the actual mask is going to go. And then so to look at it from a resource qualifier perspective, we have these two button welcomes that we can include, and then both of those point to a single drawable that actually defines the outline. And so we've created this fairly interesting complex button purely out of XML. And that makes it very easy to change, because if we want to change the color of the ripple or we want to change the color of the outline, we can do that without, design can just give us a new set of colors, and we can do that very quickly. Another big shift in the way we think about assets is to use vector drawables. So like I said, the shapes allow you to do very simple things like just blocks of colors. Vector drawables basically lets you draw whatever you want inside of them. And so this is a whole set of the vector drawables that we have set up in the Trello app. And so now you can include this in your application. It renders It renders it great, and then also you don't need to have different density items anymore. You can just have a single vector drawable, because vector just defines how to draw, based on its bounds. It doesn't have to, so it instantly scales to any density. So that's all well and good. Plus there's a backwards compatible version of this in the support library. So it's just been added in the most recent versions of Android, but you can backport it to fairly old versions. But there's one problem with vector drawables, which is that vector drawables are not SVGs. So Android came up with its own format for how vector drawables are going to work, and it's a slightly different format than scalable vector graphics, which is what the web speaks, but more importantly, it's sort of what your designers will probably be more familiar with, because I don't know of any designers right now who speak native vector drawables. I don't think there's any Photoshop edit programs that let you write directly to vector drawable at the moment. So there's kind of two ways around this issue. One is to have an SVG to vector draw. There's ways to get to SVG to convert into vector drawables. And one of those is in Android Studio. There's a new vector asset that you can, a wizard that you can create. So this allows you then to take your SVGs that you get from design, and then it'll automatically convert it into something that can be used on Android. But there's a few limitations there that have always sort of bothered me. One is that it doesn't actually work with all SVGs. It only works with a subset of them. And it turns out the SVGs we get from the Trello designers don't quite work with them that well. But the other one is that this just isn't very automatic. Like every time you want to import a new SVG, you have to go through this wizard. So we actually wrote a library before all of this stuff existed, but we've kept using it just because it's easier, called Victor. And what Victor does is it takes your SVGs and automatically converts into something that the Android app can use, and then you can just define a directory, like any sort of source set, and it'll take all those SVGs from there and apply it to the application. And the original version of Victor actually took those SVGs and would rasterize them into pings, so they would pretty much be backwards compatible. Now that vector drawables are backwards compatible as well, we have like some experimental support that actually pipes it through what the Android Studio wizard is doing. It pipes through like a library that does essentially the same thing and then spits out vector drawables. So that I found that to be a lot easier, especially because what our design actually has a Git repository where they have all of their SVGs stored. And so we just have like a Git submodule point like in our repo that points towards their directory, so they can just update their assets whenever they want. They don't even have to tell us. Like they'll just update the submodule pointer. All right, and so the last trick regarding drawables. So I'd like to point out the difference between skeuomorphic design and flat design before we get started on this. So skeuomorphic design is like on the left. This is an app called AndyGraph that a friend wrote, and it basically imports like TI calculators into your phone as long as you have a legal ROM. And it's very skeuomorphic in that it looks exactly like the actual TI-83 Plus calculator. It's even got like a nice little gradient shade on every button. You compare that to like the calculator on the right, and the calculator on the right is very flat and it has just flat colors for everything, no gradients whatsoever. And it turns out that it's really great for design, for quick turnaround in design, that we're going with flat design now. Because skeuomorphic, it's very hard to tweak any of the assets without actually getting new assets from design. But with flat, because it's just a single color, it's actually very easy to tint those colors into something else. So all of our assets in the Trello app are actually, with a few exceptions, are just black and alpha. So we have this like black and alpha Trello logo. And then in code, we can tint that to be whatever we want it to be. So if design ever decides, oh, I'd like it a slightly different shade of this icon, then it's very easy for us to go in and change it. It's almost no effort whatsoever. It's fairly easy to tint images. There's 3 different ways of doing it in Android right now. The first, you can do it via XML. The problem is that it's not backwards compatible to do it via XML, so I'm not even gonna like cover how to do it because like it'll be useful in 3 or 4 years. The simple way to do it is that you can actually call drawable.setColorFilter, and then you pass in the color and then the correct porter-duff mode for a black on alpha icon. If you porter-duff is just the way that like 2 images are a color is composited onto the image. So if you're curious what all the different modes means, there's some pretty cool articles online. But that turns out to be the mode that works best for this situation. And drawables have this method, and image views have this method, and it works fairly well. A really comprehensive solution for this, though, is supplied by the support library, and they have this drawable compat. And you can pass in your drawable, wrap it, and then you can call setTint or setTintList. And really what the comprehensive method gives you that the just simple setColorFilter doesn't give you is the ability to handle color state lists. So if you want to tint a whole bunch of states at once, like for some clickable button or something, then it's really handy for that. But at least in the Trello app, we've never actually needed that. So I just use the simpler one, which doesn't involve any wrapping whatsoever. All right, so that's what I've got. Here is my Twitter account link. Some of the stuff I talked about today, I've had other talks that are very similar to it. Like last Droidcon New York, I talked about styles and themes, but like slightly more in depth. So there's like the speaker deck if you want to go check that out and like see a more in-depth version of some of these things. And thank you very much for listening. I have a question. What's up?
So with Victor, when you generate assets, Android Studio doesn't know about them and complains that I can't find them. Is there a good way to work around?
Nope. So this is a question about Victor, the plugin, because I realize no one can hear it otherwise. So it's Victor, the plugin. There is a part of the Gradle, the Android Gradle plugin, which allows you to like say this task that I'm running is going to generate resources, and those resources are going to be imported into the app. The problem is that it's a little buggy right now in that if you're in XML and you reference like a drawable that you created, it like won't recognize that it exists even though it can compile fine. And so it'll show these like the little red squiggly lines saying like, I don't think this drawable exists, man, like you're going down the wrong path. Unfortunately, like I've been complaining about this for years and they haven't fixed it. So hopefully someday they'll fix it, but for the moment, like the advantage of automatically generating SVGs to like something that we can use has outweighed that minor difficulty. So, I think I'm out of time, but if there's any other questions, come and see me later.